Hello everybody, this is Frédéric Wang from Megaya.
Can you hear
In
the
this talk,
sound?
I'll give an update of the MathML work in Chromium since the last BlinkOn. So let's start with a quick introduction. On this slide, you can see a simple formula written in HTML using only basic text layout. And it states a nice approximation. The square root of 1776 is almost 42. But we can actually do better. So if you consider instead the square root of 1848, it can be written as a continued fraction 42 plus 1 over 1 plus 1 over 2 times 42 plus 1 over 1 plus 1 over 2 times 42 plus etc. And now it is written in MathML, which provides support for more complex layout, as you can see. Unfortunately, it's still necessary to enable experimental web platform features in order to properly render that formula in Chrome. And on this slide, MathML is used to render the Euler-Maclaurin formula in Chromium, which involves more advanced math layout, such as stretch references or large operators. And in addition to be more useful than my silly qualities, I chose that formula because it leads to mathematical questions that are very similar to what people keep asking us about MathML. First, can you tell us about the integration into official Chromium releases? Second, can you estimate the remaining work? And finally, third, since implementation can always be refined, what is good enough for an initial release? So these questions will be addressed in this breakout session. But before that, I just want to digress a bit and mention two fun facts. First, what is often considered the first computer program of history was actually about calculating these binary numbers bk that are displayed in this formula. And second, in the first volume of the Art of Computer Programming, the Euler-Maclaurin formula is described as a basic concept for asymptotic analysis. If we think about it, these are actually more than just amusing coincidences. They remind that mathematics have been instrumental and ubiquitous for human knowledge, and so getting native support on the web is something very important. So during BlinkOn 15, a very detailed list of tasks was provided with explanation of their status. Here, we will focus on incomplete tasks from the initial roadmap, as well as others that we think are relevant before I intend to ship. So regarding the initial roadmap, there are a couple of items that we consider essentially done, even if they could be improved in the future. For instance, we mentioned that switch operators are supported, but they lead to issues with min-max content weights that cannot currently be mirrored in right to left direction. This has not changed since the last BlinkOn, and we expect the same will be true for the initial release. Another of these items was about the operator dictionary. The math working group has been changing a lot its entries, but that dictionary is finally frozen, and we updated it in Chromium early this year. So finally, the most serious issues to address on this initial roadmap is the table support. We'll come back to this later. Regarding the tasks that were not in the initial roadmap, we continue to keep an eye on a few aspects such as interoperability, CSS compatibility, and security. We completed the work on ink matrix and font family math, as we will see later. The summary is that once we finish the work on tables, we believe we can finally send the intent to ship. So let's start with the achievement for ink matrix. So on this slide, the top formula corresponds to the implementation represented at BlinkOn 15. And the bottom formula is the same, but using ink matrix for token elements. And if you look carefully, you can notice some extra vertical gaps inside the top formula compared to the bottom formula. Maybe the most obvious difference is at the binary number bk that were mentioned before. But one can also see other differences for scripts, and these extra gaps in turn affect size of stretchy fences. The conclusion is that by implementing ink metrics, we have been able to improve significantly the MathML rendering. However, some stuff could be improved because we only made Blink force box metrics of MathML token elements to match ink metrics of the text. The drawback of this approach is that for rectangular glyphs, this can make the background almost fully covered by ink drawing. If we compare with other engines, WebKit uses a proprietary CSS property, which seems to make the size slightly bigger. But that's still bad because it adds corresponding gaps into formulas. And Firefox has a more sophisticated implementation. It uses ink metrics for box positioning, but normal metrics to draw the background. However, other math engines like LaTeX or Word don't do that. So it's not really clear we want the same for MathML. The conclusion is that we believe Blink's 1 is good enough for first version. And let's check the status for font family math. So math expressions not only require special symbols, but also extra data provided by the open-type math table, such as dedicated layout parameters or stretchy constructions. This means that except for very simple cases, mathematical formulas will render poorly if you just inherit the font family used for the surrounding text. As you know, CSS has generic families like monospace to describe C-state fonts with special features. And in the level 4 of the specification, the math keyword was introduced to describe font design for math layout. So the straightforward solution to our problem is actually to make the UI style sheet use that font family for math tags. This is good, but font family math was not implemented yet in Chromium. So first, as explained in BlinkOn 15, the font family implementation inherited from WebKit is very complex and has many issues. So we had to do some preliminary work before being able to implement new generic families, such as writing design docs, refactoring code, or improving text coverage. Next, we've been implementing support for font family math instead of a hard-coded value. We can now use a preference with a default value that depends on the platform and make it configurable by users. However, there are two warnings. As for other generic name, it's only implemented on non-Android platform. In any case, this is only helpful for platform with a pre-installed math fonts available or on which users can install their own fonts, which is not the case on Android. So in order to give you an idea, this is a screenshot of the font settings menu that you can see when experimental web platform features are enabled. It's reusing existing UI, except that it's more relevant to display a sophisticated mathematical formula in the preview instead of just a simple text. That way, users can check how the selected font works with math-specific layout features. And to finish this review, let's look at the issues with math tables. So as a reminder, these are similar to HTML tables. They are typically used for matrix-like expression, but also for various kinds of tabular layout that happened in mathematical formulas. So people who read the CSS transform spec will probably recognize the expression of the three-dimensional rotation matrix on this slide. The red frames for each cell correspond to the MTD elements, while the blue frames correspond to a direct M-row child. And rendering looks almost okay, except that the MathML spec says the zeros on the last row should really be horizontally centered. In the past, we implemented that via the proprietary text-align WebKit Center property. However, the M row takes the full available inline size here, so centering has basically no effect. Now, if you remove this direct M row child from each shell, things get even worse. Every child now takes the full available inline size, causing a line break to happen after each of them. And the randoming looks pretty bad, and it's probably the biggest issue we need to address. To be honest, we haven't really started to tackle that issue, but there are two possible ideas. First, if we wrap anonymous MRO, we can probably move back to the first case where the annoying line breaking does not happen anymore. Next, the core issue is that MathML elements are implemented as blocks and take the fully available inline size. Or however, there is an exception. The inline math elements do not behave that way. And actually, if you do a pure CSS table layout with inline math tag as a direct child of each shell, you basically obtain the expected layouts. So perhaps one option could be to have an anonymous MRO providing the correct size. Of course, this will need more deeper analysis, debugging, and discussion, but that's basically the ideas we have for now. So to summarize, in order to integrate MathML into official builds, we will first put all our effort on the table issues in the coming months. And then if everything goes as expected, we plan to send an intent to ship, and probably we can do that at the WebEngine Hackfest in June. And when it's approved, we can turn the flag on and we'll have some eventual fine tuning. But we'll cross finger and hopefully everything will be good. So this is the end of the presentation. I'm providing an animated GIF showing our implementation progress. And that's it. Now I guess we can move to questions. Hello. Okay, so I hope you enjoyed this presentation. So, well, as I said, we can move to questions if you have some. Maybe you have to do two amendments to the presentations. One of the things is that in one of the slides, I mentioned that font family mass, there is an emoji saying that font family mass is still work in progress, but actually all the CLs landed before, well, some weeks ago. So now this is essentially done. And the other thing is that Brian and Ian and I got some chat 1 hour ago, and we had some good idea about how to fix this table issue. So I guess now we can make more progress. So yeah, I don't know how much time we have, but I guess we can start. I want to discuss more things. So for those who are not familiar with hopping, I think in order to participate in the discussion, you have to click this share audio and video button. Okay, I don't hear anyone speaking, but I can check the chat. Okay. So I don't see any question, but people are congratulating, so thank you. So I guess if there isn't any questions or comments, we can just stop this presentation. So thank you, everybody.